In this redox reaction, we need to find the values of, we need to balance this redox equation and find the values of M, N, and P and Q. Now, the first thing again is you first have to determine whether it is a redox reaction or not. So we need to find the oxidation states of all the elements in this. So hydrogen over here is +1. Iodine, it would be -1 except when it is bonded with oxygen. So in this case, it is X because it is bonded with oxygen, and oxygen is -2. And if we add up all the charges, they should equal 0. So X in this case comes out to be +1. So we can rewrite the oxidation states. Hydrogen is +1, iodine is +1, oxygen is -2. Similarly, iodine over here, it's a free element, so the oxidation state of iodine over here is 0. And you have HiO3 where hydrogen is +1. Iodine again is bonded with oxygen, so its oxidation state is unknown. So that is X, and oxygen is -2, and there are three of these, so it's -2 into 3. And if we add up all of them, the net charge on this entire molecule is 0, so it's equal to 0. And X in this case comes out to be, +5. So iodine over here is +5, whereas hydrogen is +1, and oxygen is -2. And in H2O, oxygen is -2 and hydrogen is +1. So which element is getting oxidized? If you look carefully, this happens to be a disproportionation reaction in which the same element is getting oxidized and the same element is getting reduced. Iodine is going from +1 and it is going to +5. So that represents oxidation. So that is oxidation. Whereas if you look carefully, there's another iodine over here which is 0. So iodine is also going from +1 to 0, which means it's a decrease in oxidation state, which also translates, which is also called reduction. So iodine is getting reduced as well. So both reduction and oxidation are happening to iodine. So when we're trying to balance this redox equation, we first need to build two half equations. Now the first one is for, let's build an equation for reduction. Now the first equation that we're going to write for reduction is iodine going from, it's going from +1 and it's going to, over here the oxidation state of iodine is 0. So this is the oxidation, and the only way you can go from +1 to 0 is if you gain 1 electron. Now we would like to introduce all the other elements which are not getting oxidized or reduced. So I+1 was actually HiO, the molecule HiO. So we can write that as HiO plus, we'll have 1 electron. Similarly, I0 was actually iodine. So if if I want to write iodine instead of I0, I would have to add half I2, and I can rewrite this entire equation. I can multiply it by 2, the entire equation. It's going to be 2 electrons plus HiO. It gives you I2. And the hydrogen and oxygen atoms are, this would be multiplied by 2 as well. The hydrogen and oxygen atoms are not balanced. So we can have a water molecule. There's water over here. So there's going to be a water molecule on this side. And still we would actually need not just one but two water molecules to balance out the oxygen, because there are, how many oxygen atoms there are? There are probably two oxygen atoms on this side. So the two hydrogen atoms over here, there are four hydrogen atoms, so I would need to add two H+1 ions to completely balance out all the atoms. And now I think they're balanced out, but we're only interested in balancing this part, HiO and I2. That would require two electrons. The rest of the molecules were simply added to balance out the number of atoms. So this is the equation for reduction, and we'll move on to oxidation. The equation for oxidation. So if I start out talking about oxidation, I+1, if you look at the equation, original equation again, there was I plus 1 and it was getting oxidized to I plus 5. So we can write that down. So we have oxidation, you have I plus 1 getting oxidized to I plus 5. And the only way you can do that is if you lose 4 electrons. So it's losing 4 electrons, and we can introduce all the other atoms. I plus 1 was actually HiO, and it was getting converted into HiO3, which was I plus 5, and it was losing 4 electrons. So 4 electrons are lost, and now we need to balance the other atoms. Hydrogen is already balanced, but there are 3 oxygens over here. So I'm going to add 3 water molecules over here. And if I add 3 water molecules, the oxygen atoms are now, actually I would just need to add 2 water molecules over here. The oxygen atoms are now balanced, but the problem now is there are 3 oxygens, the 3 oxygens on this side, and the hydrogen atoms are not balanced. So I would need to add 4H plus 1 on this side. So this over here was the these were the parts that I was interested in. The hydrogen ions and the water molecules are added just to balance out the equation. So we now have 2 equations, this one and this one, the reduction and the oxidation equation. So this one was the reduction equation, this one was the oxidation equation. The last thing I need to do is I need to balance the number of electrons. There are 4 electrons being lost over here and the 2 electrons being gained over here. So I need to multiply this entire equation by 2. And if I multiply it by 2 and I rewrite this equation, it would be 4H plus 1 plus 4 electrons plus 4 HiO, which gives me 2I2 plus 4H2O. So it gives me this. So this is these are my final 2 equations, this one and this one, and I need to simply add all of them together. Both the reduction and oxidation half equations are added together. So you're going to have the overall equation is going to be, I'm adding 1 and I'm adding it to this one 2. So 1 and 2 are being added together. So the overall equation in this case is going to be, it's going to be 4H plus 1 plus 4 electrons plus 4 HiO, and I'm going to add these two to it. So it's going to be plus 2 H2O plus HiO again, and it's going to produce 2I2 plus 4 H2O, and I'm going to add this to it. It's going to be plus HiO3, and we're going to have plus 4 electrons again, and then 4H plus 1. So we have this overall equation, and if you look carefully, uh, these two add up together. That's going to be 5HiO. The 4 electrons and the 4 electrons over here cancel out. The 4H plus 1s and the 4H plus 1s over here cancel out. So, and plus the 2H2O and this 4H2O, that also cancels out. So you're only going to have 2H2O. So the overall equation now is it's going to be 5HiO, and it's going to produce 2I2 plus you're going to have 1 HiO3, and you're going to have 2 H2O molecules. M thus is equal to 5, and you have N, which is equal to 2, and M and P would be equal to 1, and Q would be equal to 2, as was stated in the original equation. So that was your answer to this question.